If you park your car on a brand new, completely rock-hard concrete driveway on day 3, you are actively destroying it from the inside out.
Oh, yeah. It is basically the ultimate hidden trap in home improvement.
Right, because you can't see it, but underneath your tires, microscopic crystals are literally shattering. I mean, you're drastically cutting the lifespan of that expensive new surface before you've even, lived with it for a full week.
Exactly. We tend to judge the strength of a surface by how it feels to the touch, but with concrete, well, human touch is just a terrible diagnostic tool.
And that is exactly what we are exploring today on this deep dive. I mean, think about it. We pass by driveways, sidewalks, and patios every single day.
You probably walked over several just today.
Right. Or maybe you have that one cracked sidewalk right outside your front door that you constantly trip over. And if you're like most people, you probably assume concrete is just a simple, mix and pour job.
Just dig a shallow hole, pour the gray sludge in, let it dry, and boom.
Boom, you've got a sidewalk. But today's mission is to uncover the hidden engineering and, really, the chemistry that separates a concrete slab that lasts 40 years from one that just starts crumbling in a single season.
Which is a really crucial distinction to make. I think we take for granted just how much structural integrity is required for these surfaces to simply exist, let alone function under immense stress day after day.
Totally. So to really get to the bottom of this, we are pulling insights today from the specialists at 479 Concrete Fort Smith.
Right, the local experts.
Yeah, these are the folks who design and build these structures in western Arkansas, which, as it turns out, is a perfect stress test laboratory for us.
No, absolutely. The climate there is intense.
Right, because when you are designing for an area with wild temperature swings, like scorching, humid summers and then freezing, icy winters, it requires some incredibly rigorous technical specifications.
It's not a forgiving environment at all.
It's really not. Okay, let's unpack this. The main theme we discovered in these sources is that the true strength of any concrete installation isn't actually what you see on the surface.
Not at all.
That smooth gray finish is just the tip of the iceberg. The real magic, the actual structural integrity, lies entirely in the invisible prep work beneath the ground. And, well, an invisible chemical process that happens after the pour.
Yeah. If we connect this to the bigger picture, concrete is ultimately at the mercy of its environment. Like, it isn't just existing in a vacuum.
Right.
Those extreme weather conditions in western Arkansas, they place immense, relentless stress on foundational materials. You have massive temperature fluctuations causing all the surrounding materials to expand and contract constantly.
It's nonstop shifting.
Exactly.
Yeah.
And without precision engineering, those environmental stressors are exactly what lead to cracking, spalling, which is when the surface flakes away, and the premature degradation of the whole slab.
It just falls apart.
Yeah.
Yeah.
So precision isn't just a nice-to-have luxury in this industry. It is the absolute baseline necessity.
Which brings us to the first massive hurdle. And this is something our sources emphasized heavily. We have to talk about the ground itself.
The dirt.
The dirt. Before a single drop of concrete is ever poured, you have to look at the dirt. I mean, it is so tempting, especially for a property owner paying for the project, to just focus on the visible surface.
Of course. You want the fun part.
Yeah, you want to pick out the design, maybe look at some color options, see the finished product. But ignoring the dirt underneath your driveway is a recipe for absolute disaster.
Because the soil isn't just a static table that you're setting the concrete on. The source material dives really deep into the specific challenges of local terrain, particularly focusing on soil with a high clay content.
Which is everywhere in Arkansas, right?
Everywhere. And you really have to understand the mechanics of clay to understand why it's the hidden enemy of concrete. People often say clay acts like a sponge, but it's actually a bit more insidious than that.
How so?
Well, on a molecular level, clay is made up of these microscopic flat plates. So when water gets into the soil, those water molecules force their way between the plates, physically pushing them apart.
Oh, wow.
Yeah, so the entire mass of the ground swells outward. Then, when the dry season hits, the water evaporates, the plates slide back together, and the ground contracts significantly.
So building on unprepared clay is basically like trying to bake a brittle cake in a flexible, wobbly pan.
That is exactly it.
Because if the pan bends even a little bit, the cake snaps.
That is a perfect way to visualize the mechanics at play here. Concrete has incredibly high compressive strength, meaning, it can take an enormous amount of weight pushing straight down on it.
Like a car.
Right. But it has notoriously low tensile strength, meaning it doesn't tolerate being stretched or bent at all.
Got it.
So if the clay underneath the slab swells up on one side because of a heavy rainstorm, it pushes upward on the concrete. The concrete tries to bend, and because it has literally no flexibility, it cracks.
So how do contractors actually fix the earth? I mean, you can't just change the geological makeup of your entire neighborhood. If you live on a bed of clay, you just live on a bed of clay.
True, you can't change the whole neighborhood, but you absolutely can. And really, you must change the immediate microenvironment directly beneath the slab.
Okay, so what's the engineering solution there?
It requires a process of total removal. Professionals don't just pour over the clay and hope for the best. They completely excavate and remove that unstable topsoil.
Wait, how much dirt are we talking about here? Because that sounds like a massive undertaking.
Oh, it is a massive undertaking. We are talking about digging down several inches, sometimes a foot or more, depending on the soil report.
Wow.
Yeah, and physically hauling all of that expansive clay off the property. Once you have a clean trench, you replace it with a highly compactable gravel base, which is known in the industry as an aggregate.
And the gravel doesn't act like the clay plates. It doesn't expand, right?
Right. Gravel doesn't absorb water into its structure at all. It allows water to naturally drain right through it.
Yeah, makes sense.
But the real magic happens during the compaction phase. Contractors use heavy vibrating machinery, like plate compactors, to aggressively shake and press the gravel down.
Just packing it in.
Exactly. The vibration causes all the jagged edges of the individual rocks to lock together like puzzle pieces.
Oh, that's cool.
Yeah, and once it is mechanically compacted, it creates this rigid, static, year-round foundation that absolutely will not shift with the seasons.
So it physical breaks the cycle of expansion and contraction.
Exactly. It prevents the foundational shifting that inevitably ruins those, rushed weekend warrior type jobs.
So, okay, we've successfully stabilized the ground below.
Right.
We've swapped the wobbly baking pan for a rigid one. But how do you ensure the concrete above doesn't crack under the massive weight of daily life?
Right, because of the cars.
Yeah, a standard cement driveway isn't just a decorative welcome mat. It acts as a functional threshold. Like, think about your own car. You are rolling thousands of pounds of moving, turning weight over that surface every single day. The concrete has to support that without buckling.
Right, and this is where we move from preparing the external environment to building the internal structure. Just like the human body needs bones to support the flesh, concrete needs an internal skeleton to handle that dynamic, moving weight.
Okay.
This brings us to the mandatory step of internal reinforcement. Before the wet concrete is even poured into the forms, contractors integrate either steel rebar grids or heavy-duty wire mesh into the empty space.
And they're suspending it right in the middle of where the slab will be, right? They aren't just laying it on the ground.
Yes, exactly. It has to be carefully elevated on little supports called chairs. That way, when the concrete is poured, the steel sits dead center in the thickness of the slab. And what's fascinating here is the physics of how these two vastly different materials work together. We mentioned earlier that concrete lacks tensile strength. It snaps when bent.
Right.
Well, steel happens to have phenomenal tensile strength. By embedding a steel skeleton inside the mixture, the steel actually holds the concrete together under tension.
Wait, I need to wrap my head around this.
Yeah.
Are you saying the steel stretches? Because I always picture steel as this incredibly rigid, unmoving thing.
I mean, it seems rigid to us, but in the realm of structural engineering, steel is highly elastic compared to concrete.
Really?
Yeah, think of the ridges on a piece of rebar. Those aren't just for grip. They allow the concrete to physically bond to the steel as it hardens. They essentially become a single composite material.
Okay, I can picture that.
So when a heavy truck drives over the slab, the concrete tries to flex and crack, but the steel inside takes that stretching force, absorbs it, and pulls the concrete back together.
Wow.
It effectively takes the highly localized pressure of a heavy vehicle tire pushing down on one small spot, and it distributes that load evenly across the entire surface area of the slab.
It's almost like the difference between someone stepping on your foot with a stiletto heel versus a flat sneaker.
Exactly.
The steel turns the stiletto into a sneaker, spreading the weight out so it doesn't cause damage. And what's really cool from the sources is that this isn't a one-size-fits-all thing.
Not at all.
The experts note that they actually calculate the optimal thickness of the concrete and the specific steel reinforcement requirements based entirely on anticipated vehicle loads.
Yep, the math dictates everything.
Right, like a residential driveway for a standard sedan gets a completely different mathematical calculation than a commercial loading dock that sees semi-trucks. It is entirely customized.
It has to be. If you
Really?
under-engineer the steel, the concrete just fails.
Okay, so we have a static earth below, thanks to the compacted aggregate base. We have a mechanical steel skeleton suspended within the forms. The concrete truck rolls up, the mix is poured, the crew smooths it out. And this is the point where most people think the job is done.
They really do.
You put up a little yellow caution tape, crack a beverage, sit back, and you just watch it quote-unquote dry. But here is where we get back to that crazy fact I mentioned right at the start of the deep dive.
The hydration process.
Yeah, because if I touch a newly poured driveway after 24 to 48 hours, it feels rock hard. I can walk on it. It seems perfectly fine. Why on earth am I being told to keep my car off it for a full 7 days?
Because this is perhaps the biggest, most dangerous misconception in all of construction. And it ruins countless DIY projects. Concrete is not drying, it is hydrating.
Hydrating? I mean, that sounds like a skincare commercial.
I know, it really does, but it's a very specific chemical reaction.
Hmm.
When you mix cement powder with water, the water doesn't just evaporate and leave behind a hard shell, like mud drying out in the sun.
Okay.
The water fundamentally reacts with the compounds in the cement to form new microscopic crystals.
Crystals.
Yeah, these crystals literally grow outward and interlock with the sand and gravel in the mix. This crystal growth process is called hydration.
Wow.
And for the concrete to achieve its maximum structural density and its full compressive strength, the moisture must remain in the mixture to feed that crystal growth.
So if you drive on it on day 3, when it feels hard to touch, but the chemical reaction is still happening?
You risk catastrophic internal damage. The surface might look completely fine to your eye, but internally, those microscopic crystal bonds haven't fully matured at all.
They're still fragile.
Exactly. The structural density simply isn't there yet to support a 2-ton vehicle. When you drive over it, the internal matrix literally fractures.
That is wild.
You are breaking the crystals before they finish growing, and you've severely weakened the lifespan of your driveway before you've even parked on it for a week.
It's an invisible chemical race against dehydration.
It really is.
And here's where it gets really interesting, because controlling that chemical reaction is incredibly difficult when you factor in the weather.
Oh, absolutely. The weather is constantly trying to ruin the chemical reaction.
Right, we talked about the extreme climate in western Arkansas earlier.
Yeah.
The professionals actually have to battle the elements to control the hydration timeline, and they are dealing with some serious thermodynamics.
Let's look at the seasonal tactics they have to employ because it's pretty intense. In the summer, you have intense direct sun and high heat.
Right.
That heat causes rapid evaporation of the water inside the concrete. If the water leaves too fast, the crystal growth just stops prematurely.
Because it ran out of food, basically.
Exactly. This leaves the surface weak and porous, leading directly to that flaking and spalling we discussed earlier.
Thus, the worst.
So to combat this, contractors don't just pour it and leave. They use specialized curing compounds and lay down moisture-retaining blankets over the fresh concrete.
Wait, sort of like a humidor for cigars? Keeping the exact right amount of ambient humidity trapped inside so the material doesn't turn to dust.
That's a great analogy, actually. Yeah, the blankets physically trap the evaporating moisture and force it back into the slab, feeding the hydration process even under the blazing sun.
That's brilliant.
Now contrast that with winter. In freezing temperatures, the threat is completely different, and this is where we have to talk about the fact that hydration is an exothermic reaction.
Exothermic meaning it generates its own heat.
Precisely. As the crystals grow, the chemical reaction actually produces heat.
Okay.
But in freezing weather, if the water inside the concrete mixture freezes and turns to ice before the chemical reaction sets, you have an absolute disaster on your hands.
Because water expands when it freezes.
Right. Ice crystals expand, and they will literally shatter the internal structure of the concrete from the inside out. It's completely unsalvageable.
Oh, man.
So in winter, contractors have to use thermal blankets. But they aren't just trying to keep the cold out, they are actively trapping the concrete's own chemical body heat to keep the internal temperature above freezing so the reaction can finish.
They are literally tucking the driveway into bed so it can incubate itself.
Pretty much, yeah.
That is so cool. It sounds like an incredibly delicate balancing act. which is why the source mentions that spring and autumn are the absolute sweet spots for concrete work.
Oh, for sure.
The mild temperatures naturally offer the most optimal curing conditions. You don't have to fight the sun with a humidor or fight the frost with a thermal blanket. Nature just lets the hydration happen at its own perfect pace.
Exactly. But honestly, regardless of the season, the masterful control of moisture during that initial curing phase is what truly separates professional, long-lasting installations from amateur attempts that crack after one winter.
All right, so we've dug out the bad dirt, we've brought in the jagged aggregate and mechanically locked it together. We've done the math on the steel skeleton, and we've meticulously managed the exothermic crystal growth.
Sounds like we've got a driveway.
Right, so we have this indestructible, scientifically sound slab of engineering, but now what? Because honestly, I don't want to stare at a boring utilitarian gray square in my backyard.
And you definitely don't have to. The aesthetic versatility of modern cement is incredibly broad.
Thank goodness.
But the crucial takeaway from our sources is that all of these aesthetic choices are only possible because of the rigorous subterranean prep and the curing process we just detailed.
Right, you can't build a pretty house on a bad foundation.
Exactly. Once the structural integrity is guaranteed, the surface can be tailored however you want.
Right, and the sources don't just list a bunch of pretty options. They get into the science of aesthetics, which I found fascinating. Let's talk about how these finishes are actually achieved without ruining the structural integrity.
Sure.
First, you've got the standard broom finish. This gives you excellent slip resistance, it's very low maintenance, and properly poured, it lasts over 30 years. This is your classic driveway or accessibility ramp.
Right. And mechanically, this is achieved by dragging a specialized broom across the surface right before it fully sets.
Okay.
It creates these microscopic valleys that allow water to drain off while providing grip for shoes and tires.
Nice and simple. Then, you step into the stamped or textured concrete. And this is where I was confused at first.
Why is that?
Well, if we just spent all this time talking about how delicate the crystal hydration process is, how on earth do contractors stamp heavy patterns into the concrete without fracturing it?
Yeah, it is entirely about timing and chemical sealants.
Timing how?
The crew has to wait for the exact window where the concrete is firm enough to support the weight of the workers and the stamping mats, but still plastic enough to take the impression.
That sounds stressful.
It's very precise. If they stamp too early, the surface tears. Too late, and the stamp won't penetrate.
Wow.
And once it's stamped and fully cured, they apply high-grade chemical sealants to protect that textured surface from UV damage and moisture penetration.
Which makes it a brilliant, permanent alternative to wood decks. Because wood rots, it splinters, you have to constantly restain it.
It's a huge hassle.
Exactly. But a properly stamped patio slab gives you a perfectly level surface for heavy outdoor kitchens or fire pits, lasts over 25 years, and offers moderate slip resistance.
It's a great upgrade.
But what about high traffic or sloped areas?
For those, the experts recommend exposed aggregate. That gives very high slip resistance, again lasting 30+ years.
But how do they expose the aggregate? Like, do they just wash away the top layer of cement? Because wouldn't that completely ruin the hydration process?
It totally would if they just washed it away with water.
Right.
Instead, they use a chemical surface retarder. They spray this chemical on the top of the freshly poured concrete.
Okay, what does that do?
The retarder essentially pauses the hydration process for just the top millimeter of the surface, while the rest of the slab underneath continues to cure and harden normally.
No way.
Yeah. So the next day, they can gently wash away that uncured top paste, revealing all the beautiful natural stones underneath without compromising the structural integrity of the slab itself.
That is incredibly clever.
Yeah.
And finally, for interior floors or covered patios, there's machine-polished concrete.
Right.
This has low slip resistance because it's smooth as glass, but it looks incredible and lasts 40+ years. And this isn't just a shiny coating, right? They are physically altering the surface.
Yes, they use massive machines fitted with industrial diamond grit pads to physically grind down the surface of the concrete.
Buffing it out.
Exactly, progressively using finer and finer grit. And during this process, they also apply chemical densifiers that react with the concrete to fill in the microscopic pores.
Oh, nice.
It makes the surface incredibly hard, completely spill-resistant, and highly reflective.
It's amazing how much chemistry goes into just making something look good.
Yeah.
But there's a vital operational component here that the sources emphasize, which ties all of this, the dirt, the steel, the chemistry, and the aesthetics, back to long-term property value.
Yeah, the bottom line here is the concept of a unified provider. The sources argue strongly for selecting a single point of accountability rather than using fragmented crews. Think about it.
Okay.
In a fragmented approach, you might hire an excavation company to dig the dirt, a completely different crew to build the wooden forms and lay the steel, and a third team to actually pour and finish the concrete.
Which sounds like an absolute nightmare. That is a recipe for the classic he said, she said when something inevitably goes wrong.
It guarantees communication breakdowns. I mean, if the excavation crew doesn't compact the aggregate correctly, the finishing crew might not even know.
Right.
They just show up, pour the concrete on a bad base, and 3 years later the driveway cracks in half. Who is responsible?
The excavators will blame the finishers will blame the steel guys.
Exactly. By using a comprehensive service that handles everything from the initial soil evaluation all the way to the final chemical sealant, you ensure consistent quality control across every single phase.
Doing the job right the first time delivers a truly measurable return on investment.
Absolutely.
It's protecting your financial value. I mean, a pristine, professionally installed driveway dramatically enhances curb appeal for potential buyers.
Huge selling point.
But it's also functional protection for your everyday life. It eliminates tripping hazards, which is a major liability. And the source points out a crucial detail: proper slope grading during the pour directs water runoff away from the home's foundation.
That's so important.
So a correctly engineered driveway is actually actively protecting your basement from flooding.
And perhaps most importantly, it avoids incredibly costly tear-outs down the road.
Oh, I bet.
If you rush the prep work, ignore the expansive clay, or fail to cure it properly, repairing bad concrete is monumentally more expensive than just installing it correctly the first time.
Because you have to undo the mistake first.
Right. You have to pay someone to jackhammer it all up, haul all that heavy debris away, and then start completely from scratch. Substandard materials and poor chemistry inevitably fail.
So, to summarize our journey today, for you, the listener, if you are looking to maximize your property value with hardscaping, or even if you just want to understand the world around you a bit better, the real secret isn't just flipping through a catalog and picking a nice stamped pattern.
Not at all.
The actual secret to a slab that lasts 40 years is respecting the science of the subgrade preparation, relying on the mathematics of the steel reinforcement, and demanding delicate moisture control during the hydration process. So what does this all mean?
Well, I think this raises an important question about how we view the built environment around us. We tend to think of a concrete driveway or a patio as this completely static, dead and natural thing that we just plop down on top of nature.
Right, it's just a rock we made and we assume it just sits there.
Exactly. But in reality, when you understand the chemistry and the physics behind it, a successful concrete slab is deeply interactive with its environment.
That makes total sense now.
It is in a constant, decades-long physical negotiation with the expanding and contracting soil beneath it and the fluctuating extreme temperatures above it. It's an active, dynamic system holding itself together under massive tension.
It's like it's holding its breath, structurally speaking, just fighting the weather in the dirt for 40 years.
Yeah.
I love that perspective.
That's a marvel of engineering, really.
It truly is. Next time you walk down the sidewalk or pull into your driveway, take a second to look twice. Think about the hidden skeleton of steel, the mechanically compacted earth, and the microscopic crystals actively holding it all together right beneath your feet. Thank you for joining us on this deep dive, and we'll catch you on the next one.